All right, Calc, last section that we're going to go over. So yay, that's exciting. This one is 14.1, 14.2. I'm not going to go through all of these problems, but it's just kind of a fun little review of algebra stuff and solving equations. So they start us off with substitution. So they give us two systems of equations. And this top one here, since it has an x squared in it, it's going to be a parabola. But since it's x or y equals x squared, it'll be a parabola going, like a u going this way, y equals x squared. This is going to be a linear function, so we have a line. So basically what they're doing here is these two functions are overlapping one another, so probably something like this. And they want us to solve the system of equations, which is where those two intersect with one another, okay? So we have to kind of somehow intertwine both of those equations together so that we can get a solution here. So they have us do this by substitution to start with. So what we need to do first is we need to solve one of the equations for one variable. Probably the easiest thing to solve for would be maybe like solving for this y down here at the bottom. Okay, so what I'm going to do is I'm going to subtract the 2x to the other side. So negative y equals negative 2x minus 1. I'm going to kind of go through this fast, so hopefully you're staying with me here. And then I'm going to divide by a negative, which is going to change all of those to be positive. So y equals 2x plus 1. Okay. Then I can take this y and I can shove him into the top equation there. So he will be x squared plus 4x minus 2x plus 1 is what I'm plugging in for that y there, equals 7. Okay, now if I distribute this through, this will be minus 2x minus 1. Okay. And so I'm going to combine some like terms here. I've got x squared, 4x minus 2x is just plus 2x. And then what I'm going to do is I'm going to bump this 7 to the other side to make it minus 7. So together with the negative 1, that will be minus 8 equals 0. Okay. And then what we want to do is we want to, since this is a trinomial, break him down. So what can you multiply to get negative 8? Well, when you add them, give you 2. And that will be a positive 4 and a negative 2. So setting those equal to 0, this will be x equals negative 4 and x equals positive 2. Okay, but there's one more thing that we have to do. We need to write those as an ordered pair. So these two places of intersection where we have this parabola and that line intersecting with each other are negative 4 comma something and 2 comma something. And we have to figure out what the somethings are. Okay. So I'm going to plug them back in, and you can plug them in wherever you want to, but this one's the easiest probably. Y equals 2x plus 1, okay? So 2 times negative 4 is going to be negative 8, plus 1 is negative 7. There we go, so negative 4, negative 7, and then if I plug 2 in, 2 times 2 is 4, plus 1 is 5. So these are going to be my 2 points where those guys are going to cross each other, okay? So normally we just have 2 linear functions that we're solving using substitution, but this is a parabola and a linear function. It doesn't make any difference. Still the same thing, okay? Now this example, substitution where there's no real solutions. So let's see what this one looks like, okay? So how do I want to do this? I'm going to solve for this y up here. Okay, so I'm going to add the x to the other side, plus x. So this y up top here would be equal to x plus 4 if I write it like that. Okay, and then what I'm going to do is I'm going to plug this x plus 4 in for that y there. So I have x squared plus x plus 4 equals 3. And if I subtract the 3 to the other side, I will have x squared plus x plus 1 equals 0. Okay, now looking at this, there's nothing that I can multiply together to give me 1, but when I add them also give me 1. So we can do the quadratic formula. So negative b would be negative 1 plus minus square root b squared would be 1 squared minus 4 times a times c. That would be that all over 2 times a, which is 1. So this is my a, this is my b, this is my c. 1, 1, 1. Okay, I'm plugging 1 in for everything. Now what we notice here is this guy inside of here, 1 squared is 1. Minus 4 times 1 would be 1 minus 4. So I have a square root of a negative 3 here. Okay. and you said forever and ever and ever that you cannot take the square root of a negative number, it ends up being no solution. So what's happening here is this parabola, because the bottom one's the parabola, and my line are not touching each other. So basically I might have something that looks like that, where I have a line, a linear function, and a parabola, and they're never going to touch. So this is an example of when that will happen, when I end up with some sort of a domain error where it's not going to work. Okay. All right. So this one is elimination, and what I'm going to have you do is we'll do this one together, and then I'll have you do maybe example 4 in this video. So when you're doing elimination, you want to find a variable that eliminates. Okay. So I noticed that if I would add these two equations, top and bottom, it's already set up to eliminate. So I have 2y minus 2y. And those can cancel each other out. And if I add the x's, I would have 8x equals 12. And I divide by 8. And 12 divided by 8 is 1.5 exactly, or you can leave it as, 3 halves or whatever you want to do, okay? But then I want to write it as an ordered pair, so I need to find this y coordinate, okay? And I'm going to plug it back in. And I don't know, when we plug it back in, let's just do the top one. We can plug it back into the top one. 3 times 1.5 plus 2y equals 4. And 3 times 1.5 is 4.5. Okay, so then when I subtract 4.5 minus 4.5, 2y will be equal to negative 0.5. And then I'm going to divide by 2. Oh boy. So negative 0.5 divided by 2. I'm just going to do a calculator. Negative 0.5. I should have left it as a decimal, but that's okay. Or a fraction. Negative 0.5 divided by 2. I don't know why I needed the calculator to do that. Negative 0.25. So these two are linear functions. They are going to cross each other. So the linear functions are going to cross each other at the point 1.5 and negative 0.25. That's what these going to look like. Okay. Now, in real world or in supply demand, like economics stuff, you might use this either substitution or elimination to find where the point of equilibrium is, which is the place where those two functions intersect one another. Okay, so the P is going to be the price in dollars, and X is the number of units that we sell. So how many units would we need to sell? This would be X, and this would be P. How many units would we need to sell in order to have the price for both of those be the same? Okay, so what I'm going to have you do is either use substitution or elimination. It doesn't matter which one. To solve for that, and we'll have you do that. Okay. All right. On the back side here, I'm going to have you also do example 5 by yourself. Okay. And they want you to use back substitution. So one thing that I notice in here is that we're dealing with 3 variables and not just 2, like x and y. Now we have a z variable. Okay. But when we use back substitution, we can see that z is already solved for. Okay. So instead of this being an ordered pair, it's going to be an ordered triple, and I have that z is 2. And I can work backwards to solve for y and then eventually solve for x and get those 2 values there. So go ahead and try to do that, try to tackle that one and see what you get. Okay? All right, now on to example 6. When you have 3 functions here where you have an x and a y and a z, it's like, where do you start going from there to get an answer? Well, the thing that I notice is in the second equation here, we are missing a z variable. Okay, so what I'm going to do, and what the easiest thing to do is, I'm going to try to combine the first and the second equation, or the first and the third equation together to get rid of the z variable so that I can then combine it with the second equation. Okay, so looking at this equation here, this top one and this bottom one, I have 3z and 5z, and if I want to eliminate those, they have to be the same number. So 3 and 5, if I think about their least common multiple, would be 15. Okay, to get 3 to be 15, I need to multiply by 5, and to get 5 to be 15, I need to multiply by 3. So the top equation, if I multiply everything through by 5, this would be 5x minus 10y plus 15z equals 45. Okay, the bottom equation, okay, would be 6x minus 15y plus 15z equals, and 3 times 17 gives me 58. I think, 58. Yep. Okay, now here's the problem. If I want z to cancel out, one of those has to be negative. So in this bottom equation, I'm going to make that a -3 that I'm going to distribute through, and I'm going to change the signs of each one of those. Okay, so there is that, and now I'm going to add the equations together. So 5x minus 6x is a -x. 10y plus 15y is plus 5y. And I get equal to, because the z's are going to go away, equal to 45 minus 58 is a -13. Okay? Now, if I combine that with my second equation, -x plus 3y equals -4. Okay? I see that the x's could cancel each other out if one of them was positive. So what I'm going to do is I'm going to change the bottom one. I'm going to multiply through by a -1. So I'll just change the sign of each one of those pieces. Okay, so I'm taking this guy times a -1. Then I notice that the x's go away. 5y minus 3y is 2y. -13 divided by 4. Of course, they couldn't give us anything really nice. That's -9. So y is going to be -9 divided by 2, which is -4.5. Okay, and then I can work backwards. So let's go with this equation. X minus 3y equals 4. That's what my second equation was. And I can plug in -4.5. Okay, -3 times -4.5 is positive 13.5. Yeah, positive 13.5. Okay, then I'm going to subtract 13.5. And I get x equals 4 minus 13.5 is -9.5. That's what my x is. And last, I can go back through and I can find z. And it doesn't matter which equation I use as long as it has a z in it. So let's do the top one. Okay, I'm going to do -9.5 minus 2 times -4.5 plus 3z equals 9. Okay, so -2 times -4.5 is going to be a positive 9. Blah, blah, blah. So -9.5 plus 9 is going to be -0.5 plus 3z equals 9. And if I add 0.5 plus 0.5, this really is not coming out very nicely, but that's okay. 3z will be 9.5, and then I'm going to divide by 3. So z will be 9.5. 9.5 divided by 3. 3.17 is what z will be. Okay, so the place where all three of those equations out in space, because this is a 3D equation, the place where all three of those are going to cross, -9.5, comma, -4.5, comma, 3.17-ish. Okay, and there is that. All right. Okay, so example 7, example 8. I'm not going to go through these, but I'm going to show you kind of like what they mean. So an inconsistent system, solving the system of linear equations, we would go through and kind of in the same process, we would solve that guy, but we would end up getting no solution for this, okay? And what would end up happening is like all of the x's or all of the y's or all of the z's would end up canceling out so that we have something that looks like, I don't know, like 4 equals -3 or something like that. Well, 4 is not equal to -3 ever, so we would end up with no solutions. And visually what that looks like if we would graph this thing is that since these are all 3 lines that are out in space, okay, maybe those 3 lines are parallel to each other, meaning they're not going to touch each other, so they would have no points of intersection. Or we could have like lines that are, since we're out in 3D, we would have lines that are skewed to one another. So maybe, this one is tilted a little bit, but they're not going to intersect because they're on different planes. I don't know, it's kind of hard for me to explain through video. But anyway, just thinking about those as being either skew or parallel lines, that would give us no solutions, okay? Now, example 8, what will end up happening is we'll have infinitely many solutions, and what will happen there is we'll get something like 4 equals 4. Well, when does 4 equal 4? Basically, everything else is going to cancel out except, either 4 equals 4, or you might end up with x equals x. Well, 4 is always equal to 4, or x is always equal to x, okay? So that means I'm going to have infinitely many solutions, and they're going to touch at infinitely many points. So these 3 lines are going to be exactly the same line, one on top of each other, okay? And that's what will happen when I have infinitely many solutions. That's kind of what he will look like, okay? But same process, he's just going to break down, and we'll end up with something that doesn't make sense up here, meaning no solutions. We'll end up with something that always makes sense down here, like 4 equals 4, and that will give me, you know, lines that live on top of one another. It's the same line, okay? So that was kind of a quick rundown of just some review of algebra, so that's kind of fun. There you go, we're done. We'll start review over the semester in my next video, and then we'll really be done.